Lesson 3.2 involves solving systems algebraically. There's really two methods to do this. In Lesson 3.1, we worked through solving systems of linear equations by graphing, and now we're going to look at substitution and elimination. So this first part will be substitution, and what we're really doing here, the substitution property of equality says if A is equal to B. So if two things are equal, A can be replaced with B in expressions and equations. So B doesn't just have to be a number. It could be 3, it could be 7, it could be 2x plus 9. It could be any expression with one or more terms. And so if we know two things are equal, if there's an equal sign in between two expressions, you can replace the first expression with the second expression. And so here we go with that. There are certain times substitution is a better choice to use, and that is if the coefficient of any of these four variables here, if the coefficient is 1, it's pretty efficient to use substitution. So in this case, this coefficient's 1, this coefficient's 1, this one's 1, and this one's -1, which is also a good choice. But what we do here is, it doesn't matter which one in this case because they're all 1 or -1. We solve for one of these four variables. So when I say one of four, I mean the first x, the first y, the second x, or the second y. And so we can solve for one of these. I'll just choose this one, this x, this first x. So to solve for that, I'm going to subtract y from both sides. And when we subtract y from both sides, we get x equals -4 minus y. And now this fits this substitution property. So x is equal to -4 minus y. So we can replace x, just like it says we can replace a with b in any expression or equation. So this is like our a, and this whole thing is our b. So we can replace anywhere we see x with -4 minus y. So what we do is we go to our other equation, the one we did not use to get this equation here. We go to our other equation and we substitute in for x. So instead of using x here, we are going to put in -4 minus y. So we have -4 minus y. We put that in here for x, because x is equal to that, minus y equals 10. And now we simplify over here. We get -4, -y minus y is -2y equals 10. We'll add 4 to both sides. And we get -2y equals 14. Dividing both sides by -2 gives us that y is -7. So we found one of our variables. Remember, when we solve systems, we're going to find the point or points that make both equations true. So we found y is -7. Now what we can do is we can take this and put it in to any of these three equations. 1, 2, our two originals, and the one we solved for x. It's actually usually easiest to plug into the one we solved for. So that's what I'm going to do. I'm going to come up here and I'm going to say x equals -4 minus y. Well, what was y equal to? It was equal to -7. So x equals -4 plus 7, which is 3. So x equals 3. We have our x value and our y value. We put our answer as a point, so 3, -7. We could go back and we could put these into each equation to check. So it's 3 and -7. So 3 plus -7 does equal -4. And 3 minus -7, which is like 3 plus 7 equals 10. So that works. Also, we could think these would be two lines. If we graph these would be two lines, and those lines would intersect at the point 3, -7. Moving right on to the next one, the coefficients here, this is a 1 for x, a 1 for y, a 3 for this x, and a 1 for this y. So really any of these choices here that I underlined we could solve for. Let's go ahead and pick this bottom one just to change it up. I don't want you to think we always solve for x or always use the first equation. So we're going to solve for this y here. You could solve for this x or this y. So I'm going to solve for this bottom y. And here I get y equals 7 minus 3x, or you could put negative 3x plus 7. That would be slope-intercept form. So now we have it in this y equals something form. So now we can use the substitution property of equality where since y equals 7 minus 3x, we can replace y anywhere else with 7 minus 3x. And we're going to do that in this first equation. So we have x plus y. But what does y equal? Y equals 7 minus 3x. 7 minus 3x equals 5. So again, we're using this x plus y. This right here is our y. So we took out y and put 7 minus 3x, and now we can solve this. We have some like terms here. X and negative 3x is negative 2x. Plus 7 equals 5. Subtracting 7 from both sides gives negative 2x equals negative 2. Dividing both sides by negative 2, you get x equals 1. So we have x equals 1. Again, we're not finished. We have to plug back into one of our original, or one of these other equations. We can use one of these first two original, or our one that we changed. Let's go ahead and plug it in here. So we have y equals 7 minus 3x. But we found that x is equal to 1. So this is y equals 7 minus 3, which is 4. So put your answer as an ordered pair. X always comes first, so 1, 4. Check if it works. 1 plus 4 does equal 5, so it works for this top one. Put it in here. 3 times 1 is 3, plus y, which is 4. That does equal 7. They both work. Our answer is 1, 4. A couple more quick examples. This next example, it's actually already set up nicely for us. We don't have to do anything because we have x equals 4y, which means we can replace x in any other expression or equation with 4y. So here we see an x. Well, we know 3. This is x is actually equal to 4y, so we're going to substitute that in there. And we have 12y plus 2y equals 8. 12y plus 2y is 14y equals 8. Divide both sides by 14. Y equals reduced by 2. Y is 4/7. And now what we want to do is we're going to take this and put it back into this one. Will be easiest. We could do either of these two, but this is nicely set up. So we have x is equal to 4 times y, and y is just 4/7. Which gives us 16/7. So we get an answer of 16/7 x value, and our y value is 4/7. So we learned graphing last lesson, and this would have been pretty hard to figure out using graphing. We could have graphed these. These are both lines, but when we graphed them, they would have intersected in kind of a strange place, and we would have had a very hard time realizing it was 16/7 and 4/7. So here, solving algebraically is going to be better. So there's our answer. We could plug that into both of these, and they would work out. Next one, 2x plus 3y equals 16. 4x plus 5y equals 28. Well, I mentioned before it's nice to have a coefficient of 1. None of these have a coefficient of 1, so there's not any that are really easy. But the next easiest thing is having a coefficient of 2, because we can deal with halves. So what we'll do here is solve for this x right here. Boxed out the whole term, but this x here. And then actually towards the end, I'll show you a quick variation that can actually make things a little bit easier. So we're going to solve for x, so we would subtract 3y from both sides first. I'm going to have to write it down here just so we have room. So 2x plus 3y equals 16. We could subtract 3y from both sides, and we get 16 minus 3y. Divide both sides or each term by 2 to get this to be a 2. And we get x is equal to 8 minus 3/2 y. So we solved for x. It's not as nice looking as the other ones that we worked with because we had integers here, but it will do. So since x is equal to 8 minus 3/2 y, in any other equation, like this one, we can take out x and put in 8 minus 3 over 2y. So let's do that. We have 4 times x, but x is 8 minus 3/2 y. So we're doing this equation plus 5y equals 28. We have to distribute here, so we have 32 minus 12/2 y, like a 4 over 1 times 3/2. Well, 12/2 is actually 6, so we'll make this 6 plus 5y equals 28. Add some like terms here. We got a negative 6y and a 5y, so we have 32 minus y, because negative 6 plus 5 is 1, so, or negative 1, equals 28. Subtracting 32 from both sides, you get negative y equals negative 4. Dividing both sides by negative 1, we get y equals 4. Now once we get here, we can go ahead and substitute this back into one of our other equations. Again, I usually said the one that you solved for is easiest. The other ones also work, but so we have x equals, so I'm looking at this one, 8 minus 3/2 y. Well, y we just found was 4. So x equals 8. We want to multiply these. This is like 4 over 1. 2 and 4 reduce. So we have 8 minus 3 times 2 is 6. So x equals 2. And our answer then is 2, because x comes first, and then 4. And I did want to show you something real quick. We did get our answer, and that wasn't too hard, but something else interesting you can do here. So we have 2x plus 3y equals 16. It's not necessary to pick this out, but I want you to see it really quickly anyway. So there it is. I'm going to use this equation to start with. So I'm going to subtract 3y from both sides. And I'll put my answer down here. So we have 2x equals 16 minus 3y. And what I want you to notice here is 4x in this equation, isn't this 2 times 2x? Right? 4x is actually 2 times 2x. So actually what we can do here, we have a 2 here. And we have 2x. Well, what is 2x equal to? 2x is actually equal to 16 minus 3y. So there's just another variation of substitution. Instead of solving all the way for x, we solved for 2x, and then if we think through our other equation in the right way, we can substitute in there. So plus 5y equals 28. So again, I have 2 times 2x, but I know 2x is 16 minus 3y, so I put this in for 2x. And now, I'm not going to complete this whole thing, but I'm going to show you we're going to get to the same thing. Distribute 32 minus 6y plus 5y equals 28. And that is actually right here. It's the same equation, just got there a little quicker without fractions. So could do it that way if it works out, but our answer is 2, 4, and that is how you solve systems of equations using substitution.